Hi everyone. You wanted me to do some more trig identities? Don't mind if I do. Let's go. Okay, so this was the homework from the a couple days ago, and I'll try and fit it all on this page, but I might need to copy some over to my blank pages. So let's get the blank pages ready. There we go. And let's get started, everybody. First thing we're going to need is to remember, okay, sine theta equals cos theta plus tan theta. This one's comes apart pretty easily. Let's start working on the right side. So the right side is cosine of theta multiplied by tan theta. But I prefer to write tan theta this way, sine theta divided by cosine theta. Okay, and then after we go ahead and get out our favorite pen, the cancellation pen, boom, boom. See, cosine is upstairs and cosine is downstairs, so the two cancel each other out, leaving us with sine theta. And that just equals the right side. So we would say that equals sine theta. It's the only thing that's left over, and that equals the left side. So therefore, left side equals right side. Done. People see how that one works? You just have to write tan theta as sine theta over cosine theta, and then find your cancellations. Boop, boop, they cancel, you're done. Okay, next one. 1 over cosine theta is equal to tan theta over sine theta. Well, let's go ahead and we'll start on the right side again. The right side here could be written as tan theta is sine theta over cosine theta. That's tan theta. But then the whole thing is divided by sine theta. Now I go ahead and flip the bottom and multiply. Huh? I don't understand. Flip the bottom and multiply. That's sine theta over 1. So this is sine theta over cosine theta multiplied by 1 over sine theta. Wouldn't you know it? I get my cancellation pen out again. I'm so pleased to do so. Bam, bam. Sine theta divided by sine theta is 1. So I'm left with 1 over cosine theta. This equals 1 over cosine theta. And that equals the left side. So we're done. Therefore, left side equals right side. All right, let's export this one to the blank pages because I don't like working horizontally. I much prefer working vertically. Sine squared theta minus cos squared theta equals, what was it, 1 minus 2 cosine squared theta? Yeah. 1 minus 2 cosine squared theta. All right. So here, let's start working with the left side. Okay, so sine squared theta, left side, we can do this. And then I can write, actually, sine squared theta. I have this identity that I'm going to draw on here. An identity means something that's, always the same. So I know that sine squared theta plus cosine squared theta equals 1. Let's rewrite this to solve for sine squared theta. Sine squared theta equals 1 minus cosine squared theta. Okay, so I'm going to substitute that in for sine squared theta there. All right, and this is what we're going to have. 1 minus cosine squared theta is the same thing as sine squared theta minus cosine squared theta. Okay, let's work that out. Well, here I just use my algebraic skills of collect like terms. I have a cosine squared theta and I subtract another cosine squared theta. So all in total, I'm subtracting 2 cosine squared thetas. And that equals the right side. So we're done. Therefore, left side equals right side. Cool. Well, let's keep going. Tan squared theta plus 1 equals 1 over cosine squared theta. Okay, doesn't look the same, but apparently it is. Let's see. Tan squared theta minus 1 equals 1 over cosine squared theta.
Plus 1.
Plus 1?
Yeah.
Oh, thank you. It wouldn't have worked if I didn't have that detail. So let's start with the left side. Okay, so left side here. We're going to say tan squared theta is equal to sine theta over cosine theta, but the whole thing is squared, plus 1. All right. I see that I'm going to have a denominator cosine squared theta on the bottom there. So let's keep going. Sine squared theta over cosine squared theta. And I would like to do this addition here as well. So I'm going to write 1 as a fraction. Okay, plus cosine squared theta over cosine squared theta. Cosine squared theta over cosine squared theta is 1. I just multiplied top and bottom by cosine squared theta. So now I have sine squared theta plus cosine squared theta over cosine squared theta. But sine squared theta plus cosine squared theta is 1. See, that was the identity I used up here. So this is equal to 1 over cosine squared theta, which is equal to the right side. There it is there. So therefore, left side equals right side. We're done. So that was number 4. Number 5, 1 minus cosine squared theta is equal to sine theta, cos theta, tan theta. Okay, sure, if you say so. 1 minus sine squared theta, was that right? No, 1 minus cosine squared theta. My goodness. I don't think that would have worked. Cosine squared theta is equal to sine theta times tan theta times cosine theta. Right?
I think the other two are swapped.
Sine theta, cos theta, tan theta. Yeah, but it's multiplication, so it can be in any order. So that's still equivalent. So let's go on the first side. 1 minus cosine squared theta. We're going to start on the left side. 1 minus cosine squared theta is actually equal to sine squared theta. Why? Well, because sine squared theta plus cosine squared theta is equal to 1. So if you subtract cosine squared theta from both sides, you'd have 1 minus cosine squared theta equals sine theta. So the left side is just equal to sine squared theta. Cool. Now let's work on the right side. So we have sine theta. I bet that's going to multiply another sine and make sine squared theta. So this is equal to sine squared theta. Let's write tan theta as multiplied by tan theta. Sine theta over cosine theta multiplied by cosine theta. And then we get our favorite pen out, the cancellation pen. Bam, bam. Sine theta times sine theta is sine squared theta equals the left side. Done. Let's keep going. Cosine squared theta, tan squared theta equals sine squared theta. Okay, this is a multiplication identity. We just need multiplication rules. I forget it already. Cosine squared theta, tan squared theta equals sine squared theta. Cosine squared theta, tan squared theta equals sine squared theta. Yeah, that one's real easy. Let's do left side. Cosine squared theta, we're just going to write that in terms of cosine and sine. That's already in terms of cosine and sine. Tan squared theta, we can write as sine squared theta over cosine squared theta. And then we notice that our cosine squared theta cancels the cosine squared theta and equals the right side, sine squared theta. Therefore, that's true. Done. Keep going. Okay, sine squared theta, tan squared theta plus cosine is equal to 1 over cosine. Oh, cool. Let's see. Sine squared theta, tan squared theta plus cosine. Oh, yeah, I can see it. All right, so let's go. Let's work over here in another color. I forget what it was. Sine, just sine theta, tan theta plus 1. Sine theta, tan theta plus cos theta. Equals 1 over cosine, right? Yeah. Okay, let's start on the left side because the right side's already quite simplified, so we're not going to make any progress working on that side. Expressing it as secant doesn't really help us, so let's go with left side. So sine theta multiplied by sine theta over cosine theta, because tan theta is just sine theta over cosine theta, plus, cosine theta, but I'm going to want to create a common denominator here. So I'm going to get out my create common denominators pen and multiply that top and bottom by cosine. Because I notice that I'm going to have to have a common denominator here of over cosine. So let's go, next line. So the left side equals that. It also equals this. Sine squared theta, that's sine theta times sine theta, plus cosine squared theta, all over cosine theta. Okay, but sine squared theta plus cosine squared theta is 1. So it's 1 over cosine theta. It is the right side. Done. Yeah.
Why didn't you do what you did before by canceling out those codes?
Like here, why don't I cancel some cosines?
Yeah.
Okay, so this is a very popular thing to want to do, and you're not allowed. I'm not allowed to say cancel that and cancel this. And I don't think you would make that mistake if they were numbers. Oh, where? Up here?
Yeah.
Up here?
Yeah.
Like here? This one? Like that?
No, but there's only two. Like it was sine theta and then sine theta over cos theta plus cos theta. Why didn't you just cross out cos theta?
Like why didn't here, sorry. Like why didn't these cancel?
Yeah.
Oh, well when I show you numbers, you'll say, "Oh, I can't cancel that." Let's say I have 3 over 5 plus 5.
I didn't notice it was adding.
Yeah, it was adding. It wasn't multiplying. Yeah, that's why. Yeah, it was adding. But that's the trick is because this is unfamiliar, you're going to forget rules that you're really confident with when it's just fractions and numbers. So if you're ever unsure, like, oh, can I cancel like over here this cosine squared with that cosine on the bottom? Just check with a number example and you'll find you can't. If I have like 3 squared plus 5 squared over 5, I am not allowed to cancel this 5 and that squared because of this addition. If I cancel it on the bottom, I have to cancel it from the top from every factor. So I would be like dividing 3 squared by 5, and it's not convenient to do that. Like if I wrote it as 3 squared divided by 5 plus 5, that would be correct. But that's weird and awkward, so don't worry about it. It's not going to help you make progress on these problems. But thinking about numbers in that example, like in that way, is absolutely useful for how you work with your fractions and how you apply some of the tricks in the later examples that happen down here. So we just did this one. Let's try this one over here. We got lots of space here, so let's do it here. Tan squared theta. That's a funny way to write tan. Tan squared theta over sine squared theta minus 1. Let's start on this side, the left side. All right. So tan squared theta is just sine squared theta over cos squared theta, all divided by sine squared theta, but I'm going to flip this one and multiply. So that's just going to be multiplied 1 over sine squared theta. That helps me see my cancellations more easily. I kind of skipped a step there. Are people okay with me flipping this and turning it into that multiplication right away? I express tan squared theta as sine squared theta over cos squared theta. I flip that and multiplied, and then I have to subtract 1 from the whole thing. This comes down here. Okay. So now let's do it. I see that I need my cancellation pen. Oh, happy days. Boom, boom. So 1 over cos squared theta minus 1. All right. Let's create a common denominator while we have this pen out. We're going to multiply that top and bottom by cos squared theta. And then we will have this line. I'll write it out for you for your viewing pleasure. This is 1 over cosine squared theta minus cosine squared theta. Okay, that's 1 times this, so that's on top. They have common denominator, so it's 1 minus that. Okay, so that's what we get on top. 1 minus cosine squared theta happens to be sine squared theta. So that equals, and why does 1 minus cos squared theta equal sine squared theta? Well, because of this. Remember that sine squared theta plus cosine squared theta is equal to 1. So if I have 1 minus cosine squared theta, that just equals sine squared theta. That's just subtract cosine squared theta from both sides. Okay, so let's keep going. So that equals sine squared theta over cosine squared theta. And you might say, well, that just equals tan squared theta. Or you might also do some work. I would prefer doing work on the left side as well. Maybe I do that in the color blue. And I also work on the right side over here, this one. So the right side is equal to tan squared theta. And I can write tan squared theta as sine squared theta over cos squared theta. And then I say, well, that equals what I found the left side to be. So therefore, left side equals right side for this one. Done. Carry on. Carry on. I want to do some of these examples. We're running a little lower on time, so I will jump to example 11. Let's see. Sine squared theta minus cosine squared theta. We're going to take a look at this one here. Let's look at sine squared theta minus, well, I see cosine squared theta can just be written as, this one is super easy. This one, by super easy, I mean, so long as you can recognize negative cosine squared theta is equal to sine squared theta minus 1, then it just adds together to give you that. It's just like very straightforward. I wanted to look at, there was a more challenging one down here that involved some funky factoring. Let's take a look at the one that's on the practice test. It's in the video, but I wanted to show you this anyway. So let's take a look at that, and then that'll be it from me for today. Here is the practice test and my solutions, which I shared with you in video form. Let's go ahead and do this example down here. Sine x plus tan, and I'll just copy it over onto a new blank page. So just give me a moment. Okay, we had it in one place in video form already, but let's talk about it here. Again, when you're looking at challenging problems like this, you want to relax and call upon as many of your past skills as possible. This one is going to require that we do the new things that we know how to do, like writing tan x as sine x over cos x. So let's start work on the left side. But there's also another skill that we need to apply, and I'll highlight it as we get there. This is going to be sine x plus sine x over cosine x. That's tan x written as in terms of sine and cosine. And then we're still going to be dividing by cos x plus 1. Now we get out our pen of create common denominators, and I notice I need a common denominator in my numerator. So if I divide this by cosine, C-O-S, cosine of x, and I multiply the top by cosine of x, I have created a common denominator without changing that thing. I just multiplied by 1. So now I can go ahead and add the tops together. But another useful thing to do here would be to say, well, this denominator could be written as cosine x plus 1 over 1. I also didn't change it. I just showed some invisible things there. So let's keep going. So I have a cosine of x, sine x, plus sine x, all divided by cosine of x. That was my numerator. Now I flip the denominator and multiply. Multiplied by 1 over cosine of x plus 1. Okay? Now, let's do a little bit of unnecessary work to show you how to then undo that little bit of unnecessary work. Okay? What? What's up? What's your question? Oh, yeah?
Where did you get the 1 over cosine?
So this is the denominator. To turn that fraction division question into a multiplication question that's easier to work on, I flip it and multiply. Okay, cool. So now, let's multiply the top times the top and the bottom times the bottom. So we're going to have all that top stuff, cosine x, sine x, plus sine x, multiplying by 1. So that just means it's itself. So we'll have on the top cosine of x, sine of x, plus sine of x, all divided by, let's multiply the bottom. Cosine x times cosine x plus cosine x times 1. I have to use my distributive property here. So that's going to give me the numerator cosine squared x plus cosine. And it looks like we can't make any more progress. How can we make more progress here? Huh?
Cancel the cosine that's multiplied by the sine with the 1 squared.
I'm not allowed to cancel this cosine here because I'm adding there. And if you change cosine to like the number 5 and sine to the number 2 and try a number example, you'll see that they don't cancel. Okay? What we can do is factor the top and factor the bottom. I see a common factor in both of these terms here, it's sine x. I see a common factor in both of these terms, it's cosine. Notice we just multiplied that factor in on the bottom. I'm now going to factor it out. And you'll see that now the problem crumbles once we do this little bit of factoring. So on the top, we will have sine x as the common factor that comes out, multiplying cosine of x plus 1. So I factored sine x out of both of those places, and it leaves cosine x plus 1. And then on the bottom, we'll just have what we had over there when we factor out cosine. Cosine of x multiplied by cosine of x plus 1. Notice that we can now get out our favorite pen and cancel those common factors. And we're left with sine x over cosine of x. We were asked to prove that that was tan x, and indeed it is. Tan x is sine x over cos x, so we are done. So you have to apply all of the skills in a new context to help you master the old skills and the new context. And I hope that was useful, and I hope it helps you approach your study over the weekend with a growth mindset and arrive on Monday with a handwritten cheat sheet. Any questions, hit me up by email over the weekend. If people want a live tutoring session over the weekend, let me know today, and I'll set one up for everyone. If people don't, no problem.